So let's start with the very first topic of this webinar. As you can see on your screen, we are going to see how to use scheduling. So a very short premise before entering the topic itself could be is why we chose to talk about this. We chose these topics because basically they are quite new developments in the software. In our opinion, they are also powerful developments. I am talking in plural because I'm not talking just about the scheduling, but also about the screen conductors. So what I am saying is that we are really convinced that they are strong and important developments, but we think that there is not enough, not enough awareness about them. So we want to show you how to use them in order you are aware how that they exist, first of all, and also that how to use them and what kind of powerful features they are able to provide you with. And also, finally, maybe also give you an idea of the developments we have in mind about them. Because, as you know, well, especially the ones who are already our users, you know that we like live the present, but also think about the future. So we always have in mind something, what's next, basically. So let's go on. What are we going to deal with in this presentation? The main points we are going to have a look at is, first of all, what is the scheduling in XGSLab? We will face how to deal with it in different ways, because there is not just one way to handle the scheduling. So basically running multiple projects or setting some parameters. We will have a look at a very practical aspect, that is to say the syntax, the shortcuts that are very useful to set up the parameters of the scheduling. We will have some simple examples. We will have a look also to messages and during the calculation. That is very useful to be clear. And also we will have a look to what is automatically exported from the project that are handled in the scheduling. This is very useful for advanced users mostly, but for anyone in any case. And also a quick look to the possible future developments. So let's go to the tool, and the scheduling is here and can be entered simply by pressing this icon. I have to specify that if you find this icon that is disabled, it means that the license you have does not allow you to handle the scheduling, basically. So once you have entered the scheduling, as you can see, you have a screen that is quite different from all the other modules in XGSLab. You have a screen that is divided into tables and with some parameters to set. So basically consider that there are two ways to trigger the scheduling. Well, first of all, what is the scheduling? The scheduling is the ability to run in a sequence. Sorry, I take this, so I will not forget what to tell you. Is the possibility to run in a sequence multiple projects. and also the possibility to modify them with some specific syntax that consider how the projects are made. So how can you trigger them, this scheduling? You can trigger it in two ways. You can add different projects. For example, we can press the plus and go, for example, in this way. We can add two projects. Let's suppose this one and also the other one. And then we can confirm we are happy with what we have imported and run the calculation by pressing compute. This is the manual way. We have also an automatic way that can be enabled by flagging this enable timer and setting a time here. So it is a time in 24 hours, consider. And so basically the Central European way to set times, and you can set an hour. It is a very useful tool, this one, because we have the chance to set the start of the calculation in, for example, in the evening when we are not in our workstation anymore. You have just seen that I have added one by one the projects. We have also in this case many different options to run, to add the projects to run in the scheduling. So we can add with the plus, we can add a complete folder. For example, if we select a folder, let's suppose we want to add all the projects that are distributed with the software itself. So for example, let's suppose we point to the projects folder in documents. And if we set OK, as you can see, the scheduler has added all the projects. Consider that if we close this now, we have lost that list. This is obviously not a problem in this case, but pay attention to this because you could lose it, but also this with the, how to say, with the the right action can be avoided very easily, because if you set up some list of projects and also some parameters that we are going to see in a moment how to set up them, you can export the Excel file that allows you to re-import it again. So for example, if we export a table, we can go here, projects, we have exported this. If we close this, we can import, go here, import, and we can have our list of, sorry, I suppose he went to the wrong place, sorry. We can go to the, this is the right one. We can go to the, have the complete list as we had it. So what to say? What we can do now is that we can see how to set up the different parameters. So, and how to do that. Before doing that, let's have a look at what kind of projects are them. So I suppose that you, since most of you are already users of XGSLab, the second project is very well known. It is the one that we distribute in the tutorial. It is the GSAFD project. So I take for granted the knowledge of that project. I'm just going to show you very quickly what is the other project, just to give you an idea of what we are going to set. So It is basically another GSAFD project. It is a project with 3 different electrodes. So you can see here. Obviously, it is very simple. I wanted to keep it simple because I want also to run the calculation and I want to waste time in the running times. So we have 3 electrodes, as said. If we color by tag the layout, we can see that the first electrode is named with the tag grid 1. We have grid 2 in green and the ring in light blue. Moreover, it is very important to notice the names of the reference points. So fault grid 1, fault ring, fault grid 2. So keep in mind this setting of the layout. We can close this project and we can open the scheduling as said. So we have to, well, just a short break to tell you that I have seen someone that has asked some questions. We have 10 minutes, let's say, at the end to ask questions, or 5 or 10 minutes of any contribution. So no worry about questions and just ask them later. So let's add the projects that we are dealing with. So first of all, this one that we have just seen with the 3 grids, and the second one, the tutorial GSAFD. So let's suppose that we want to change the fault point in the 3 different reference points we have seen. So we have to press the right button of our mouse, enter parameter editor. We have to append a new record, select energization. And what do we have to do? We have to set the names of the different reference points that we want to make as faulted point. So for example, we have fault grid 1 as first. Then we have to use the vertical bar, fault grid 2. Then we have to use the vertical bar and fault ring. Okay, and at the end of this string, we have to place the fault current we want to use. So for example, 1000 amperes. There is a very simple trick to set the phase of the fault current, that is from pressing Ctrl plus P. And so you have seen that there is the symbol of the phase. So we can set 25 degrees of phase, for example. We can also add other options. So let's suppose we want to set that some tags are switched off in some case. So let's suppose, since the tags we have seen before, that we want some calculation that in where the grid 1 is switched off, and some other calculation where the ring, the tag ring, is switched off. While I am writing, have a look at this. The calculation that will be launched later, they will be a sort of anything against any case against any other case. So basically, this number is very useful to pay attention to avoid a huge number of cases. So I know that sometimes scheduling can be, how to say, exciting as an automatic tool, but pay attention to avoid a high number of cases, especially because here I am trying a very simple case with a low number of elements and a uniform soil model. But in some other cases, you can have also TD projects, for example, and in that case, you know that the the calculation takes a much longer time. Consider that we have also the chance to change the frequency in case we want, and there is also at the moment the striking distance for shield projects as a parameter to be set. In this case, anyway, we feel happy to keep this kind of parameters, and we press this confirmation icon in order to keep them. As you can see, we have all the complete list here. In this other project, we are not going to change the injection current or anything else. We are going to do something else because in the scheduling, we have also the chance to do something else. For example, beyond the parameters, we can tell the software to generate automatically at each calculation, in this case just one, the distribution pictures. So, for example, we can set, I don't know, the leakage current, for example. Let's suppose we are interested in the 1D format of that picture. We want it complete with the modulus, a real part and the imaginary part, and nothing else, basically. Obviously, if we know something more about the filters, we are free to add them. What we have to pay attention in the scheduling is that we have not pre-filled in combo automatic drop-down menus. Why this? Because we have not opened the project, so we have not the chance to make this possible. Basically, you have to take note of the data to set before. Let's suppose we want also the potential distribution into the version. And let's suppose also we want the current distribution in 3D version. And we can press confirm. Moreover, we can also set up some area calculation. We can enter the different parameters of the area calculation, so we can dial them very simply here, but we have another much more interesting option, that is the importation of some pre-calculated area calculation. So if we press this icon and we go to take this file is, all the users of XGSLab know this, is the area calculation, the last area calculation saved. So if you take this file, it is automatically imported, at least not about the results, but about the parameters. So you're not importing the calculation because that file could be also related to an old calculation, so not valid anymore. But what we are interested in is the dimension of the area, the step of the calculation, and anything else. And we could have multiple of them. So we can also press confirm in this, and the same we can do about the line calculation. And anything is valid in the same way. Consider that what we have done here for the images can be done also with the parameters. So you have many different results available. So here we can confirm the parameters. When we have confirmed, we can go here to run the calculation. So now the calculation has started, and it is very interesting to see the different messages that are running here below. So you have already seen some error. This is something that was expected, and I wanted to show you this. Why this? Because this first project had some parameters set, as you remember. So we set in these parameters that the injection point had to change in 3 different locations. At the same time, we set also that some tags had to be switched off. Obviously, I told you also that there is a sort of multiple combination of all the cases. So if you set the injection point in a tag that is switched off, obviously this cannot work, and the calculation is not successful, obviously, in this case. Okay. So this is about the sorry, we have just a moment. Let's try to do. So basically, this is the sequence of saving all the projects. Consider that any calculation corresponds to the saving of a new XGSLab file. So this is also the reason why you have to pay attention to the number of the cases that you are going to set up in case you set parameters. We can have a look to the folder where we are running this calculation. And we can see that we are filling this calculation with the different cases. Just a moment. Okay. So basically consider that we have there is okay. Basically what we can see, for example, is the list of these projects. Just a moment. We have the list of these projects. We can open one of them, for example. This one, for example, or better, this one. Okay, that is one of the ones that were successfully calculated. You have that the name of the file already tells you what has done, basically. That is to say that we have, first of all, the tag that is switched off, that is the grid1 tag. And in the second part of the name, fault grid2 is the default point that has been set. And this is exactly what has happened. If we use this icon to see this, we can see that the grid 1 has been switched off. And again, we can see that the fault has been set in the grid 2, and the fault ring is the one that is still there to be a floating electrode. Okay, so we can go on with the other case. Can save it. Just to tell you about the other cases, sorry, not this. We can also add the case of the shield. In the shield project, we can use the parameters to enter, as said, also the striking distance. So in case you want to test the same shield project for different striking distance, for example, you can do 10 or 20 meters, for example, in this case, and you can run the calculation the same. let's say that, well, let's see what is the time needed. If it is something reasonable, we can wait it to the end. Okay, we can wait it. In the meantime, we will. I also tell you some other detail about the scheduling. Let's say that the scheduling, as anticipated, not only saves the projects, but also saves automatically some tables or results. And this is very useful. And we can see the previous projects that we have seen. For example, this one that we used as a parametric analysis. We have that automatically the calculation that is run saves the elements table. So for any scheduling projects, you have the elements table that is saved when you deal with FD projects. So this is very important to consider, because we will see that in case of TD calculations, we will have a higher amount of output data saved. Okay, so we have that this is complete. We have these two shield projects run that were completed correctly. And just a moment. Okay. And we can see that, for example, this is the first one, the one with 10 meters as striking distance. And we can see, obviously, in all the different ways that the shield module allow. So also the new way that we recently have developed. And we can also have a look, well, we can also avoid to have a look at it, but the one with the 20 meters is a bit the same. Finally, before letting you some time for the questions, consider that if you have the TD projects in the scheduling, obviously the time needed is much longer, so this is the reason why we do not try it live. But what is very important to know is that the software, in this case, automatically in the folder reports, reports, no, sorry, not in this one, because it was the mother project, but the other ones, okay. In the folder reports, we have all these files that are saved. What are they about? They are the files about all the distributions, about all the reference points of the project. So not only the reference, but also the injection point. So you have, for example, CR are the distribution for the current. EF are the ones for the electromotive force. LL is the linear leakage current, LS the superficial leakage current, and PT is the potential. So basically what you find here is, for example, in this case, you find the about the point corner. You find the behavior of the potential on the time. So you find all the different curves of, this is the one in time domain, this is in the frequency domain. So this is, I am aware of it, a very quick overview about scheduling, but I would like also to let you some time for questions. So please ask me in case you have questions. Otherwise, I can show you some detail more. While I wait for questions, I take the chance to do this further calculation. So anyway, if you think to, if you have some doubt, please ask. There is really nothing to be afraid of. Previously, I was not to run very quickly. I was not very accurate in showing you all the details about the chance of okay, so I see that there is some questions. Well, I can answer. Okay, I see. Well, the seminar will be recorded. I hope you can see my screen for the ones that was not able. Okay. Okay, change it. So let me understand correctly your cases. So first of all, let me export this table. Okay. So how to read the results from a certain element by a name. At the moment, I suppose that this is a question from Edward Schulzenko. At the moment, this is not possible by setting the value of the element. Let's say that it is possible by setting a reference. Let's say that we also should say that we are going to face a sort of revolution on the graphical output and the interaction of this software. So I think that there will be great news in the months to come. So about this, we will see for sure a solution to be more precise in selecting some element. How to change 3 parameters for the same case, I cannot understand very well. That is to say that, for example, just to stay in this case, I can choose, for example, different energization point, different tags to switch off, different frequencies also. And we can do this. I don't know exactly the 3 parameters what are meant to be. But this is the question from Wolfgang Emmer, if you can specify about this. From Mr. Gayala, an export of layout enabled issues. This is, well, there is an export of the layout in Shield that is enabled for the picture of the layout, let's say, or about also the export in DXF format. I don't know exactly. Well, if you mean the export of the protection volume, this is not exportable in this moment, but we can make it exportable anyway. So, well, if there are other questions, otherwise I run very quickly this calculation. There is also someone else that is trying to enter, please. Okay. So just to tell you what I am doing now, and then we will, then I also beg you to make the other questions if you can, is that we are running a calculation where there are also areas and distribution pictures. Basically, this way to do the scheduling allows you to prepare a calculation in order to have all the things prepared for a report, for example. As you can see, the messages here below are telling you that we have run the calculation. We have basically run the area calculation, and at the end we have closed the project. Now, if we open this project, that is the one that we have just run, we find it that it is already calculated, but also if we go to summary and gallery, we find exactly the picture that we set before. So this is the picture about the leakage current, and we set exactly to have a 1D with both modular real part and imaginary part, and also the potential in 2D. What we also set was the area calculation that now can be recollected very quickly by using the load tool, and in the folder calculations we can load it and view the result. So as you can see, everything is prepared. Obviously, you have to imagine to be able to run scheduling that has got both parameters and post-processing procedures. So in this case, you have a really powerful tool that is able to run a large bunch of calculations automatically. And in case of sequence calculations, you can you have no difficulty to do that.